Greetings, everyone. I hope everyone's having a great Sunday. Anyway, today's the presentation day, so here we go. Presentation. Let's do it. So, the overview. This will explore the basics of the uses of Linux and how to install it, as well as focusing on its application in both server and desktop environments. Desktop being computers that sit on a desk. No offense, as much as I like laptops myself, I feel like they don't have the kick it needed for Linux and whatnot. Anyway, the topics covered will include the various Linux distributions, system requirements for installation, partitioning strategies, that means separating stuff and like ordering and whatnot, and the step-by-step process of installing a Linux operating system. Additionally, we will examine common post-installation tasks such as package management, user account setup, file permissions, and system maintenance. The research methodology includes a comprehensive review of technical manuals, peer-reviewed articles, and hands-on experiments in virtualized environments to demonstrate installation techniques and usage scenarios effectively. So some of y'all might not know what Linux even is. So I'm going to give you the definition of it. Linux is an open source, which basically means available to the public, Unix-like, which means it's a term for like multitasking and multi-user computers, operating system, but that's what OS means. That is versatile for servers and desktops, computers that sit on desks, not laptops. Now, some popular versions of Linux are called Ubuntu, Fedora, CentOS, and Debian. So, hey, I'm over here. So, don't mind the hands. The model literally cannot like bend the fingers. We're talking hardcore stuff, like hardware. Okay, that kind of rhymed. But nonetheless, I did this as a way to try to transmit everything into like we're talking about hardware. Yeah. Hardware requirements. I really hope that was understandable because I'm not doing another take. Uh, the hardware requirements for Linux can vary depending on distribution and what you're going to use it for. However, here's some general spectorals. Now, for minimal specs, you're going to need a CPU that is one GHz single core processor, at least. By the way, this is all for the minimum. You're going to need at least 512 megabytes of RAM, 2.5 gigabytes of hard drive space, preferably in the system files drive, and a video graphics array. You're going to need a video graphics array capable of 1024 times 768 screen resolution, basically the amount of pixels the screen takes up or has. Think of it like the YouTube videos, 144p, 240p, and 360p. Those are all like resolution in regards to like pixels and whatnot. Recommended specs. Now you're gonna need a GHz core processor, which is like it has two GHz, it has two cores and stuff. You're gonna have to have 4 gigabytes of RAM, and for storage you're gonna have to have 25 gigabytes of hard drive space. And for your display, you're going to need 1024 times 768 or higher resolution pixels. And don't worry if you have more. If anything, like I have a lot more than this on my own desktop computer. So don't worry if you have more than this. Now let's talk the differences between the server and the desktop installations. For starters, the graphical user interface. Now, with the desktop, the graphical user interface usually comes with it, for ease of use. While with servers, typically they don't have graphical user interfaces by default in order to save resources and instead are managed by the command lines or the command terminal, which is much cooler to say in my opinion, which is used to interface with stuff. Let's talk software packages, which are programs and the such. Desktop computers already include software for general use as web browsers, office suites, and multimedia tools. While with servers, these come with server-specific software, such as web servers, which is like what the web browsers access, database servers, which is stuff like where web servers and what in the computers and whatnot take data from, or use data from, like draw from, and virtualization tools, which are things that are used to run certain operating systems on certain computers, or other operating systems on computers. Like you can use like virtual machine, an application such as that. I believe uses virtualization tools, which then allows you to run like Linux on a Windows computer. Pretty cool, huh? Now let's talk optimization. Is anything optimized? To answer that, things do get optimized. Desktop usually are optimized for usability productivity with a focus on user experience. And while servers are optimized for performance and scalability, often running in headless setups, basically without the monitor or head, and without peripherals 45.
Peripheral or external devices connecting to a computer to expand its capabilities. Now, while servers don't have peripherals such as keyboards, mice, monitors, and /OR printers, they still have the core components including CPUs, motherboards, and RAM. The servers don't have peripheral in order to increase performance by using the bare necessities.
When it comes to Linux, the primary is speed. That and the open-mindedness of the community, but nonetheless, Linux can go fast, like this, bang! Like teleportation. Oh, so cool. Kernel versions of Linux. There's quite many of them, as the Linux kernel is continuously updated. The current stable version is 6.11 as of November 2024, which is when I'm making this. However, long-term support versions, or otherwise known as LTS versions, include 6.1, 5.15, 5.10, 5.4, and 4.1967.
A long-term support release is associated with an application or operating system in which you have security, maintenance, and sometimes feature updates for longer durations. LTS versions are considered to be the most stable releases which undergo much testing and include years of improvements. It is important to note that an LTS version of the software does not necessarily mean feature updates unless there's new LTS releases. What? You will get necessary bug and security fixes with LTS.
Let's talk dependencies. Dependencies in Linux are additional packages or libraries required for a software package to function properly. They could be runtime dependencies, those ones are needed for the software to even run. Build dependencies, those are required to compile the software from the source. And package dependencies, other packages that the software relies on. The importance of partitioning. Partitioning a disk in Linux is crucial for several reasons. Organization, for one. It helps in organizing data efficiently, making it easier to manage and locate files, such as putting things in folders or binders in real life. So you can have organize everything by name and or color, so you can find it easier. Then there's performance. Smaller file systems are more efficient and can be optimized for specific tasks. Like coming home from the grocery store with a bunch of groceries. They're all stored in like these little baggies and whatnot. You can carry multiples of these little baggies at a time, but you can only carry so many. You take time carrying only so many that you can carry up the stairs and into the house. While if you were to carry all of them at once, without the little bags, it's just like in one big bag. That could be hard to carry because instead you have to drag it or hoist it with your shoulder, and that's crushing your back, and you're like walking like the Hunchback of Notre Dame. Rest in peace, Notre Dame. Then there's security, isolating different types of types of data, such as system files, user files, and the whatnot. Doing this can enhance security by limiting the impact of potential attacks, as it not only because it's like easier to go through, but anything that gets slipped in might be more easily noticeable. Recovery. It simplifies backup and the recovery processes, as you can restore specific partitions without affecting others. Let's talk about partitioning the computer into three parts, or separating it into three main parts. The root, which is basically the slash. It will contain the core system files. Keeping it separate ensures that user data doesn't interfere with the system operations. Next comes the home. We store the user data in the personal files here. The separation allows for easier backups and system upgrades without affecting user data, though this is something that is ultimately optional. Then comes the swap. It acts as an overflow for the RAM. Having a dedicated swap partition can improve system performance, especially on systems with limited RAM. Since version Ubuntu 18.04, a separate swap partition in most desktops has been superseded by a swap file within the root itself. A separate swap partition is no longer recommended for most new desktop users. Now, I can understand how this might seem redundant, but I believe it's worth mentioning nonetheless. Now, the benefits this gives to security, performance, and manageability. For security, the benefits are by isolating the system files from user files, you can apply different security policies to each partition, reducing the risk of system compromise, like what I just did with my voice. For performance, smaller dedicated partitions can be optimized for specific tasks, leading to better overall system performance. For manageability, separate partitions make it easier to manage disk space, perform backups, and recover from errors. That one is especially important. For example, you can reinstall the operating system without affecting user data stored in the home. Now, I can understand how you might be a bit confused. How could there be types of partitions? Ultimately, it's just separating one thing from the other. Well, let us talk about that. A couple of partitions that are considered standard. For example, primary partitions. Up to 4 primary partitions per disk. They're used primarily for bootable partitions. Then comes the extended partitions. Those are a type of primary partition that can contain multiple logical partitions, overcoming the 4-partition limit.
LVM stands for Logical Volume Manager, a mechanism that provides an alternative method of managing storage systems than the traditional partition-based one. In LVM, instead of creating partitions, you create logical volumes, and then you can just as easily mount those volumes in your file system as you did this partition. One exception to the previous statement is that you cannot use logical volumes for /boot. That is because Grub, the most common bootloader for Linux, can read from logical volumes. The well-known alternative to Grub, systemd, on the other hand, reads only VFAT file systems, so that's not going to work either. Components of LVM. There are 3 main components to LVM. Physical volumes, volume groups, logical volumes.
Logical volume management has a couple benefits that I believe are worth noting. Flexibility, which is basically the allowing of resizing of partitions and combining multiple disks into a single logical volume, as well as the creation of snapshots, which those are primarily used as backups and testing. One might call to mind the use of them when it comes to Minecraft, a video game made by a company called Microsoft.
A partition table, GPT, is a modern partitioning system used for organizing storage devices like hard drives or SSDs, designed under the UEFI standard and replaces the older BIOS system. It supports larger disks, over 2 terabits, and up to 128 partitions. It also offers data redundancy. Sounds unnecessary, but hear me out. By storing a backup partition table at the end of the drive, enhancing data integrity and recovery options if the primary table happens to become damaged.
Let's talk about the pre-installation checklist. And by that I mean we're checking off stuff that we have to do before we install in Linux. Let's talk about the backups. Now, before installing Linux, it is very important, I mean deeply important, that you back up all your important data to avoid data loss. That goes for if you're using a computer that already has data on it or a computer that you just got brand new. Please do use tools like rsync, DataJupe, or just regular old cloud services, though the cloud services part is unpreferable, as it has been shown many a time before that cloud services have forgotten things. I would suggest personally using a hard drive or an SD card that you keep secure. Finally! Yes! Installation! Concerning the installation of Linux, well, to put it simply, you might find yourself frustrated when presented with problems on, perhaps, how to install it in the first place, and what they could go on from there. And those problems may cause even more frustrations, and some frustrations may cause you to cause problems. For yourself, that is. I'm here to help prevent that, or at least attempt to, so that you become this instead of this. Or this. Let's say you have a USB or DVD which is installed with Linux. So, you must insert said bootable USB or DVD and then restart your computer. Then access the boot menu, usually by pressing F12, F10, or Escape during the startup of the computer, and then select the bootable media via the file system that is presented. When it comes to installing Linux, there are two types. Clean installation. This will erase the entire disk and then install Linux as the only operating system. This is why here we have backups, because some people have mistakenly clicked clean installation, thinking it was something else, or just by accident. So it's always helpful to have a backup. And then there's dual boot. This allows you to install Linux alongside another operating system. For example, Windows. You'll need to partition your disk to allocate space for Linux in this situation though. Then comes the whole process of configuring the language, the time zone, and the keyboard layout for your computer. During the installation process, you'll be prompted to select these things. So please do ensure that your system is configured to your proper regional settings. I wouldn't want anyone to be late to anything. After setting up the time, the date, and the region, you will be asked how to set up your partitioning. Now, you can manually partition, which means to create the partitions for the root, the home, and the swap. This setup helps in managing system and user data separately, as mentioned before. But then there's automatic partitioning, which lets the install automatically partition the disk. Now this is simpler and easier for you to do. You have to do less work and whatnot, but be warned, it is less flexible, as it's not set up with the intricacies that you yourself may put in. Next comes the package selection, such as for the desktop environment and any additional tools you may choose. First, please do choose your desktop environment, such as GNOME, KDE, or XFCE, based on your preferences. Then, select additional tools and software packages you need during the installation process. Now comes the final installation and the very first ever boot for the Linux system. Once the installation is complete, the system will prompt you to remove the installation media and reboot. On first boot, you will be greeted with your new Linux system. Congratulations! Yay! Now, complete any initial setup steps, such as creating a user account and configuring system settings. Package management systems. Let's start with apt. Using Debian-based distributions, such as Ubuntu, commands include apt-get and apt-cache. Yum, used in said operating system in older versions of Fedora, and has been largely replaced by DNF. As for DNF, let's talk about it. The next generation package manager for Fedora, CentOS, and RHEL. RHEL. It improves on Yum with better performance and dependency resolution. Pacman. Waka waka. The package management manager for Arch Linux. It uses simple commands like pacman -S for installing packages like in Pacman -SYU for updating the system. For installing and updating software, you must use your package manager specific to your distribution, and that is what we're going to be talking about right now. For example, sudo apt install package underscore name for Debian-based systems, as well as sudo dnf install package underscore name is for Fedora. Also, sudo pacman -S package underscore name is for Arch. Now, for updating stuff, you're going to want to use sudo apt update and sudo apt upgrade for Debian-based systems. See? It's very similar to the package manager, except you replace install with update or upgrade. Sudo dnf update is for Fedora, and sudo pacman, that's SYU, for Arch. Let's talk user account setup, such as the difference between root and regular users. So, the root user has full administrative privileges. Basically, they can do whatever, while regular users have limited permissions. It's a best practice to perform daily tasks as a regular user and use sudo to execute commands with root privileges when necessary, as it not only will help you know what your limits are in regards to being a regular user, but also solidify in your mind the commands for sudo. As for creating new user accounts, you must use the user add and the add user command. For example, sudo add user new username will create a new user and prompt you to set up a password. Let's talk file permissions. There are three basic file permissions: read, write, and execute. These permissions can be set for the owner, group, and or others. The red is for the user owner, the green is for the group owner, and the purple is for the other. Now, when it comes to changing ownership and permissions, one must also use commands for that, such as the chmod, which changes the permissions of a file or directory. For example, chmod 755 file name sets the permissions to read, write, and execute for the red area, which is the user owner, read, nothing, execute for the green area, which is the group owner, and then read, nothing, execute for the purple, which is other. Next is chown, which changes the ownership of a file or directory. For example, chown user group file name changes the owner to user and the group to group. In order to keep your system secure and up to date, you must patch your system. Regularly update your system is crucial for security and stability, so please do use your package manager to check for and install updates. Examples include Debian-based systems which use the sudo apt update and sudo apt upgrade. Fedora and CentOS operating systems use sudo dnf update. Arch Linux uses sudo pacman-syu, and one of the best things you do is enable automatic updates if supported by your distribution to ensure you don't miss critical patches. Backup strategies. Such backup strategies include setting up automatic backups. Automating your backups ensure that your data is regularly saved without manual intervention. You can use tools like rsync and cron to set up automated backups. Let's talk about them, shall we? rsync is a powerful tool for copying and synchronizing files and directories. For example, the command rsync-av-delete /source/directory/backup/directory that will back up your save data for that thing. Next is cron, which is a time-based job scheduler in Unix like operating systems. You can create a cron job to run rsync at regular intervals. Example, cron job to run daily at 2 a.m. is 0 space 2 star star star, spaces in between stars as to be precise, rsync space dash av space dash dash delete space /source/directory/backup/directory. Now is managing your logs. But that entails checking system logs for errors, which are typically stored in the var log directory. Key logs to check include syslog, which is the general system log, which is either located in var log syslog or var log messages. Next is uth.log, authentication logs, which are stored in var log uth.log. Next is dmesg, which are the kernel ring buffer messages. Those are stored in var log dmesg. Next is you can use commands like tail, less, and grep to view and search for logs. For example, sudo tail -f var log syslog to view the latest entries in real time. Now, there's something called log rotation and cleanup. Log rotation helps manage log file sizes and ensures old logs are archived and deleted appropriately. The log rotate utility is commonly used for this purpose. Configuration files are typically found in ec logrotate.d. Example configuration for rotating log weekly and keeping 4 weeks of logs. Key differences. Such key differences include headless versus GUI-based installations. Headless installations are without graphical interfaces. They are typically used for servers where resources are conserved, and remote management is done by command line interfaces, like SSH. While GUI-based installations use a graphical user interface, as per the name, making them more user-friendly for desktop environments. They are suitable for users who prefer visual interaction with the system. Another example of key differences are server roles, such as that of web servers and database servers. Web servers host websites and web applications. Common software includes Apache, Nginx, and LightTPT. Database servers handle storage data, retrieval, and management. Popular database servers include MySQL, standard query language, PostgreSQL, and MongoDB. Desktop applications are also another set of key differences. Such things as Office suites, which are applications like LibreOffice and OpenOffice, which provide word processing, spreadsheet, and presentation tools, and media players, with applications like VLC, Rhythmbox, and SM Player, which are used for playing audio and video files. Another set of key differences involves server tasks, specialized server tasks, in regards to hosting services, such as the different servers which are used to host services. Web servers and FTP servers are among them. Web servers use software like Apache or Nginx to host websites. Configuration files are typically found in the etc Apache 2 or etc Nginx, while FTP servers use software like VSFTPD or ProFTPD to manage file transfers. Configuration files are usually in the etc VSFTPD or the etc ProfFTPD directories. In regards to managing multiple users and permissions, use commands like user add, user mod, and user delete to manage the user counts, and then set file permissions using chmod and change file ownership with chown. For example, chmod 755 file name sets read, write, and execute permissions for the owner, and read and execute permissions for others. When monitoring servers and optimizing them, one must use tools like anything else. Such monitoring tools include tools such as htop, vmstat, and iostat, which are used to monitor system performance. For the log analysis, one must regularly check logs and var log for errors and performance issues. And for optimization, you must tune the system performance by adjusting kernel parameters, optimizing application configurations, and using caching mechanisms like varnish or redis. However, what is overall important to all this is security, stability, performance, and efficiency, as well as troubleshooting. Security is the proper installation and post-installation practices to ensure the system is most secure from the outset, including reducing the risk of vulnerabilities and attacks. For stability and performance, a well-configured system is more stable and not only performs better but looks better too, providing a smoother user experience and reducing downtime. That and efficiency, understanding these processes allow for efficient system management, saving time and resources in the long run. Last is troubleshooting. Familiarity with installing and post-installing steps makes it easier to troubleshoot and resolve any issues that may arise. Thank you for listening. I hope this was informative. If anyone has any suggestions on how to better this, I shall be willing to hear them. I also hope everyone has a great day and a great night. Goodbye.